Okay, this is chapter 8, and we are in section 8.5, and this is video number 2. Okay, so this example talking about nicotine content of cigarettes. For whatever reason, they want to know about the variance of the nicotine content. Uh, might be a little more sensible to be talking about variance of medications, right? Because really, what difference does it make if the nicotine content varies that much? But again, this is a metaphor, so the exact same techniques could be used for other types of problems. Okay, so we assume it's normally distributed, which is one of our requirements. We got a random sample of 20 cigarettes. Okay, so 20 n is 20, has a standard deviation of 1, and alpha equals 0.5. Is there enough evidence to reject the manufacturer's claim? So the claim is, so the null hypothesis is that it is the variance is 0.644. The alternative hypothesis is that it's not equal to 0.644. Okay, so this is going to be a two-tailed test. As always, we got to find the critical values. Alpha is 5%. That's what it says right up here. So the only thing that matters is what the alpha is. For the critical values, all you need is the alpha, and you need the degrees of freedom. So degree of freedom is 19 because you have a sample of 20. So we want a degree of freedom of 19 and an alpha of 0.05, but it has to be half of 0.05. It has to be 2.5% over here, 2.5% over here. So it's going to be a two-tailed test. So I'm going to do that for you. I think you deserve one more shot here at me doing this. Okay. Okay, so to find these critical values, as always, we look first of all over here, degree of freedom. There's the sample size is 20, so degree of freedom is 19. We want the two. Let me bounce back over here. Okay. Okay, we want this guy and we want this guy because we want 2.5% over here, 2.5% over here. This table, as I've said before, always shows to the right. The area to the right. That's the cartoon down here. Oh my gosh. That's the cartoon. That's this cartoon down here to remind you of that. Okay. You can barely see that, but it's there. Okay. So now let us do this. We'll go up here to the, we have to try to, this is not easy, folks. Okay, 19 is the degree of freedom. So you go across here in order to find the appropriate alpha. Let me see if I can move this appropriately. Give me a second here. Okay, I hope this is going to work. So the degree of freedom is 19, and I want to go to the column that shows 2.5% to the right and 2.5% to the left. So just like we've done before, the 2.5% to the left for this row right here means I go to the one that says 0.975. That's this guy right here, and that's the chi-squared left, 8.907. Then to find the guy that is appropriate for showing 2.5% to the right. Okay. This is not working. Well, folks, I'm going to have to assume you know how to do this, okay? I just can't get it done. Okay, we did a couple of those already. So the point of this story is you find the two critical values, the 8.907, and then you find this other one, the 32.852. So it's a two-tailed test. So you do this first. You do this first, and then you compute the test value. You come up with a test value, 29.5. All you do is plug it into the formula, and when you come up with the formula, 29.5, where do you end up? Strangely enough, he didn't mark it on here. The 29.5 is in between these two critical values. He's in here somewhere. It doesn't matter exactly where he is. He's in this region where you do not reject the null hypothesis. So, since you're in that region of not rejecting, what you say then is, as a conclusion, oh, here it is. Okay, here it is. So 29.5 is between the 32.8 the 32 and some change and the 8 and some change. So we're in between the two critical values. So there's not enough evidence to reject the manufacturer's claim that the variance is equal to 0.644. And that kind of makes sense, right? I mean, if you really thought about it, wouldn't you say, well, the manufacturer claims 0.644. I did a test and I came up with a sample of 1, okay? I'm sorry, I came up with a test. I am kind of lost here. Okay, so the manufacturer says the variance is 0.644. I came up with with 20 cigarettes that had this standard deviation of 1. Okay, is that significantly different from 0.644? So unless you do this for a living and you specifically do this kind of a problem with cigarettes, your intuition doesn't tell you whether it's significant or not, but at least it's reasonable. At least you're not just totally blown away like, oh my God, that's a ridiculous result. It's kind of a sanity check. All right, so when you do that, you come in here and you say, well, I'm not going to reject the null hypothesis. It's close enough to being the 0.644. Okay, so now we want to talk about the p-values. The same idea before with the p-values. P-values always do the same thing. With the p-values, you find the exact probability of getting that particular result. So it's really nothing new. It's just using these tables. The most important thing is for you to understand what does a p-value mean, because if you read any papers, they're going to give you the p-value. So you need to understand that the p-value is the probability of achieving or obtaining that exact test value or a more extreme test value. So look up that definition, make sure you understand it, because that's what you're going to see in the papers if you read a scientific journal. Okay, you're not going to do the tables, in other words. You're going to just get it off of the computer. Okay, so find the p-value if chi-squared is equal to this, n is that, and the test is right-tailed. Okay, well, fine, no problema, okay? So the p-value, put this up here. Okay, chi-squared is 19.274, n is 8. So if n is 8, that tells me that the degree of freedom is 7. Okay, and I'm looking for chi-squared of 19.24. So I go across here, I go across here, I go across here. Okay, there it is. It's between 18.475 and 20.78, right? That's just finding the number. Okay, well, once I find that number, the corresponding probabilities are right up here. So what that's telling me is that it's between 1% and 0.5%. Okay, so as I mentioned before, we always typically in America we write from left to right. So it's 0.005 on the left. The p-value is between 0.005 and 0.01, okay? And if you did it on a calculator, you'd come up with 0.007. So, you know, somewhere in the middle there, okay? So it's kind of an old-fashioned skill to be able to use these tables, but the reason the author does it, I think, is because it really helps you understand these tables. Okay, so I'm going to leave the other ones to you. I think they're pretty straightforward. Okay, so that's the end of this recording for section 8-5.